Hi, welcome to Learning Monkey. I am Raghuveer. In this class, we'll discuss about isomorphism of groups. In our previous classes, we clearly discussed about homomorphism of groups. Please watch that class and come back here. The link for the playlist is provided in the description below. Coming to today's class, so the definition, first we try to understand the definition isomorphism, but with example you are going to get clarity. A mapping F from a group G star. G star is a group, here the binary operation is star, to a group H delta, to another group H delta, here the binary operation is delta, is said to be isomorphism. When we are going to say it as isomorphism mapping, it has to satisfy three conditions. What's those conditions? The first condition, F is a homomorphism. First it has to satisfy the homomorphic property. What's the homomorphic condition? It has to satisfy F of A star B. Star is the binary operation from G. And delta is the binary operation from H. F of A, delta, F of B. If it satisfies this condition for all the A comma B belongs to the set G, then we say it as homomorphism. So the first condition you need to check for homomorphism. The second condition is F should be one-to-one function. And F is a onto function. If it is one-to-one and onto means if it is a bijective function, then we say it as isomorphism. With example, you are going to get clarity. Let's take the example G 1 omega omega square on multiplication operator. So this is a group which we already discussed about this in our last classes, in our examples. So 1 omega omega square means cube roots of unity on the multiplication operation. This is how the table looks like. So these discussions made, what's this table, how we got this table, these discussions made in our previous classes. We are not going to do it again. And the second group is H is equal to 0, 1, 2. These are the set of elements on addition modulo 3 operation. So this is the table which we got with this with this group H. So what's this table? 0 plus 0, which is 0 modulus 3, which is 0. 0 plus 1, 1. 1 modulus 3 is 1. 0 plus 2, 2. 2 modulus 3 means 2. Similarly, 1 plus 0, 1. 1 modulus 3 means 1. That's why we got 1 here. 1 plus 1, 2. 2 modulus 3 means 2. 1 plus 2, 3. 3 modulus 3 means 0. This is how we got this table. Same. This operation applied on all the values 0, 1, 2, 0, 1, 2. The same way we got this table. 1 omega omega square, 1 omega omega square. And the operation here is multiplication. Here addition modulo 3. These are the two groups we are taking. And the function F from G to H. Every function is having some equation. Some mappings will be there. What's the mappings that we are going to consider here? The mappings here is F of 1 is equal to 0, F of omega is equal to 1, F of omega square is equal to 2. These are the mappings. Is this function F from G to H, is it isomorphism? Yes, it is isomorphic function. Why? We have to check for three conditions. What's those conditions? First, you have to check for whether this function is homomorphism or not. Homomorphism or not means take any two values F of A multiplied by B. So these A, B values from the set G. G means 1 omega omega square. You take any two values. Here we are showing only one example. You try to do it for all the examples. It is going to satisfy this condition. F of 1 multiplied by omega. The two values which we considered here is 1 comma omega. F of 1 multiplied by omega. F of 1 multiplied by omega means omega. F of omega means, so from the mapping, F of omega means 1. So the output is 1. This should be equal to F of A addition modulo 3 F of B. F of A means here 1. F of B means omega. F of 1 means 0. F of omega means 1. In between these two, you apply addition modulo 3. That is what homomorphism says. 0 plus 1 modulus 3. 1 modulus 3 is 1. So we got the same values. It is satisfying this condition. So it is a homomorphism. And the next two condition, whether it is a bisective function or not. Bisective function means 1 to 1 and on to. See here, it is a bisective function. 1 omega omega square, 1 mapping to 0, 1 omega mapping to 1, omega square mapping to 2. 3 elements, differently mapping. So it is 1 to 1. All the elements here are mapping to head mapping. So it is onto function. So it is both 1 to 1 and onto function. Now this we call it as isomorphism. Hope you understand what isomorphism means. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.